everything that's in this lesson, and I have to review the circle relationships, but it's a matter of solving problems. So you need to write something down. Okay? I'm going to think out loud. If you write nothing, you haven't tried anything. That's what you have to do. First thing we have to do is remember the circle relationships, and right here we had a couple of them. If I have a line that is tangent to the circle, so this line is tangent to my circle, then this angle is going to be a right angle. Do you remember that? A radius is always perpendicular to the tangent line. Okay, there's that one. And what's this whole unit about anyway? Right, and right triangles. So guess what? If you don't get a right triangle, something's wrong. So you know that. Then we have to also remember this other conjecture. And if this is the center of the circle, then what is this segment? It's the diameter. And we should all know that. And TJ, do you remember if you inscribe an angle in a semicircle, how many degrees is a semicircle? That's 180.
I was going to say that, Garrett.
So how big is this angle then? No, remember inscribed angles are half, not 30, 60, 90. I'm glad you said that though. Okay, why am I glad that he said 30, 60, 90? You have to be told it's a 30, 60, 90, or you have to know, because where do 30, 60, 90s come from? They come from equilateral triangles. Okay, girls? And where do the 45, 45, 90 triangles come from? Squares. So you either have to tell you it's isosceles, or they have to tell you the angles are 30, 60, and 90, or you can't use those nice little theorems we did yesterday, which is unfortunate because I like them because it makes things easier. Then you're just stuck with Pythagorean theorems or the Pythagorean triples. Do you remember the triples? Because I think it might be good to talk about this. Remember a 3, 4. TJ, do you remember? 3, 4 what? 5. Hey, guys? I'd write those down. Do you remember how to generate them? Question, Miles? You square this and divide it in half. So if I take 5 and I square that, it's 25. What's halfway? TJ? What's half of 25? 12 and 13. I don't know if they went through this with your other teachers, but I did. So if you have 7, you go 49, which is 50. So half of 50 is 25. So this is 24. 25. Well, it's half 49. I can't do half 49. So what's 9? Square 9.
81.
81.
Which is 40, 41.
40 and 41. That's right. So then I forget to do the 11s. You guys know what 11 squared is?
121.
121. 60 and 61. Okay, one thing that I don't think you're getting, because we haven't done similarity, is that, you guys, if you have a 3, 4, 5 triangle here, 5 being the hypotenuse, and you make it bigger, you double it, for instance, that's 10, that's 6, and that's 8. The ratios still are the same. The ratio is still 3 to 4 to 5, 6 to 8 to 10, still the same ratio. That's why the 30, 60, 90s work and the 45, 45, 90s work. Okay? Riley, headset off. Okay. Those, and there's evens. There's an 8, 15, and 17. That one's harder to generate. I take half of 8, which is 4, squared, 16, and take the numbers either side of 16. They're just harder. So we might look for some of those as well. Otherwise, if you don't have a special triangle, or you don't have 30, 60, 90s, or 45, 45, 90s, you have to use Pythagorean theorem. There's no other way. Okay, so this is all problem solving today. So when I first looked at that problem, it's kind of scary looking. Okay, so if you don't have, I don't think this is on the worksheet. So we'd like to create a plan. I like to mark on my diagram what I know. And I know that TA is 12 square root of 3. I also have a 30-degree angle here. What's this angle at A? It's a tangent. That's a radius. It's perpendicular. So what's this angle? 60. Okay, so if I can block out the picture a little bit, I get some ideas. I want the shaded region. I see a triangle there, but really what I see, if I'm careful about this, I see a circle and it's missing a piece, or a pizza or a pie. Mrs. Richards brought treats today. She made a giant brownie. She put cream cheese and whipping cream and strawberries and probably a little more fruits on it. It's really good. So, of course, when I go back there won't be anything left. But for a while, it looked like that, as people started eating this. So it does look like Pac-Man a little bit. So I want this area. I want the shaded region. So what I do is just figure out, I want this, I figure out what I have to do to find that. Well, it's not quite a full circle, is it?
Yeah, no.
So how do you find it? The area of the shaded region is what? Well, let's figure out what we have to find. This is 60. So what's left? So what's been taken away is 60 out of 360, or 1/6. How much of the pie is left?
The rest of the pie is.
Well, if you've eaten 1/6, there's 5/6 left. Now, what's the area of a circle? Pi r squared. That's the number of degrees in a circle, 360. Okay, so what I'm doing is breaking it down. I labeled the side here, which I actually want to move, and I figured out what I want there. I want the yellow region, so it's 5/6 of the pie. What do I have to know? TJ? What do I have to know to find the area? The radius. Okay, I'm going to move this guy out of the way for right now. And this is how we do the problems. You should be writing this down. We are going to take my triangle, and which side is the hypotenuse? Yeah, which one is that? I know which one it is. It's TN. Everybody with me on that? This is a 30, 60, 90. That's 2x. Then what's this side? X. And this is?
X is 3.
Now notice I don't have the numbers there. I took them away. Now I'm going to put them back. Because that's true for every 30, 60, 90. They always reduce to the same ratios. So now I'm going to put this back, and still I have people not believing what I've written. They write these things down, and they still don't believe it. We have x square root of 3 equals 12 square root of 3. What's going to happen to the square root of 3's? I mean, you can multiply it out if you want, but I don't want to do that. Cancel. So what's x equal to? 12. That's my radius. Now, I don't have my calculator handy. So here's what I'm going to do, because I can do this without a calculator, and you can too. It's 5/6 pi, and then it's 12 times 12. Now, I know that's 144, but I don't know how many times 6 goes into 144, quite honestly. Why would I know that? But I do know how many times 6 goes into 12. So I'm showing you a little number sense here. 6 goes into 6 once, goes into 12 twice. Now, the order in which I multiply is not important. Okay, Garrett? Garrison? Garrett. Yep. Sorry. You guys have similar names. I could multiply the 2 times 12, 24 times 5. I don't know what that is. And I could do it. It's not hard. Or I could do 5 times 2, because that's 10. And 10 times 12 is? It's 10 times 12. 120 pi. Okay, so I don't need a calculator, not all the time. Yep. I think the calculator gets in the way. But we'll see. So we're going to go through all of this, and I'll hand you back your little quizzes, and then you'll make corrections. We'll work on those tomorrow. We review tomorrow. So tomorrow's a work day, and then Friday's your test. You're going to make corrections on. Okay. Here we go. I have this picture here. I want the area of the shaded region. Well, what's the plan? Well, I could mark in what I know. That'd be good. There we go. And by the way, do you remember what this little piece is called? I don't eat this on pizza or pie. That's where all the calories are. It's the crust. But do you remember what that little piece is called? Segment. Segment. This is a segment. Now, do you remember how to find the area of a segment? You're going to find, you're going to find this piece of pie, and you're going to only eat the good stuff, the filling. Not circle, but you're right. Take the area of the sector. Do you remember that's called a sector? Minus the area of the triangle. Okay? Elena, I need you with me. How do you find the area of the sector? Oh, I guess I better put some stuff in here. AB is 6. What's true with this length? AC is also what? 6. It's equilateral. So how big is this angle? This length is 6. This is 60. Okay? So what do I need to find this, the area of the sector? This is 60. What part of the circle? We just did this. What part of the circle is that? It's 1/6, right? So this is 1/6 of the circle, which is pi r squared, minus the area of a triangle. There is a formula, Miles, for the area of a triangle, for equilateral triangles, but we won't do that unless you want me to. But it's 1/2 what? Base times height. Now you guys should remember area of a triangle. It's not that hard. Here's a parallelogram. What's the area of a parallelogram? Base times height. What's true about a triangle? It's what part of that parallelogram? Yeah. That's why it's 1/2 base times height. You can remember base times height. You've been doing that for years. Okay? Okay. So I need to know the radius. Oh, guess what? I do know the radius. What's the radius? I know the radius. Do you? Okay. What's the base of my triangle? 6. What's the thing I don't know? The height. So I'm going to take that triangle out and draw it bigger because I don't have enough room. I think so. This is 6. Let's draw in the height. This is 60. This is 30. And we know that's 6. So we know what that little length is right here. That's 3. As long as any side is half the hypotenuse, you know you have a 30, 60, 90. So then this is 3 times the square root of 3, because this is 2x, this is x square root of 3. Okay, and that's the height, so 3 square root of 3. There we go. Do I have everything for my problem? Yeah. I don't know if this is on the worksheet, because I don't give away all my worksheet. So it's 1/6 of pi. I still don't have a calculator, which is 6, and now it's r squared, so it's 6 times 6, minus 1/2. And we have some issues with multiplying these out, I found out. But they're not that hard. Think about it logically. Okay, Jacob? What happens to the 6's? They cancel. Now, I could have taken 1/6 of 36. I mean, it's not like it was hard, but that's okay. This is easier. Now, how do you do the next one? I could multiply the 6 times 3. You know, the square root of 3 is different. It looks different, so guess what? I can't do anything with it. So we just leave that guy alone, and I could take half of 6, which is 3. And 3 times 3 is 9. Square root of 3. Some of you guys like to add those or subtract them. You get crazy things. That can't happen. They're not the same. And it goes back to, and again, I'm going to ask you this. Why is it you can add 3x and 5x? And it's not because your teacher told you. Okay, Miles? We're doing math. Because we factor out an x, we're left with 3 plus 5. And guess what? I know how to do 3 plus 5. That's 8. Well, what could I factor out of here so I'd be left to something I could add or subtract? All I can take out is a 3, and it just doesn't do me any good. So you can't do that. Okay, do you guys need to have different seats? Okay, Jake, have you done this problem now? No. Okay, let's try that one. What's the plan here? Yes.
The last problem. You're on like a test. We just
I want you to leave your answer like this. Yes. That's it. Okay. How about that one? What's the plan there? I want the shaded region. First, write in what I know. AB is 10. So this whole thing is 10. So how long are each of these little sections? 5. Now you probably make a good guess of what those angles are. At least I hope. D is the center. AB is 10. Triangle ABC is isosceles with AC being equal to BC. Which means that if that's 90, how big is this angle? 45. This angle is 45. It's like a puzzle. And because this angle is inscribed in a semicircle, because this is the diameter, how big is this big angle up here? 90. So that's 90. And then what has to be true about each of these little ones? 45. You get a bunch of 45, 45, 90 triangles. So how do you get the area of the shaded region? Hey, Suze, how are you going to get that? Good. Area of the circle minus area of the triangle. Keep going till you actually get stuck. Can you all see that? I'm going to take the circle, I'm going to cut out that triangle. How do you find the circle? It's pi what? R squared. I know you guys don't like to write the formulas down, but it really works. Minus, area of a triangle is 1/2 base times height. And there's a couple ways to do that problem. Okay, do I know the radius? Oh, sure I know the radius. So it's pi times 5 squared minus 1/2. Now, I don't care how you do this triangle. You can take, and actually it's easiest to take this as your base, and then this is your height. So how big is the base? 10. And it's easier than you think. If this is 5, and that's 45 degrees, and that's 45 degrees, how long is that segment? And it's a radius besides. Now keep it simple. This is a radius, that's a radius. It's 5. They're congruent because it's isosceles. Okay? Riley should be doing these problems. You should be writing them down. And so the height is 5. Now I could have done it with AC as the base and BC as the height. I'll get the same answer. Doesn't matter. That's just a little harder to work with. This was easier. And I don't always know what's easier. It's whatever I see. So I'm going to get 25 pi here. Minus half of 10 is 5 minus 25. Can I add those? Let's factor out a 25. Let's find out. I'm left with pi minus 1. Can I take pi minus 1? I mean, I could if I go to decimals, but I can't do anything with it. No. So now you've learned why you combine similar terms. I may have to come back and repeat that again, because that's important. Because later on, in some more advanced classes, you're going to have to understand how to do that. If you won't be able to do the problems. Ooh, I thought this was a strange one, but it does relate to the Olympics quite a bit. Because, you know, they have to stay within these tracks. If you're downhill skiing, you've got to stay within the poles. Right? I don't know which skiing. They have so many different kinds of skiing. I don't know. Do you guys know how fast they go? 80 miles per hour. First off, I'm not even sure I like driving my car that fast, much less to be going down a hill at 80 miles per hour. If you hit anything, you're done. It's true. Or if you wipe out, you could break your leg very easily. Well, this is like a track. You got to stay on the track. So I didn't understand this question at first. When I first read it, they give us a hint, which is nice. And it's 6 meters wide. So this is 6 meters. I didn't know if I drew that quite right. And the radius of the inner circle is 24. Where should I draw the radius? I should draw it. What's 24? O to any, not A, but we can use O to A, because guess what? This is 24. This is how long? 6. So this whole segment is 30. Now, I may be writing down stuff I don't need. I never know. I just write it down. Where's a better place? There's a perpendicular here. The radius to the tangent line gives me a right triangle. Okay? How long is this segment? 24. I heard somebody say that. I heard that. No, I'm actually amazed at how good my hearing is. Okay. And it says, I want the longest straight path that stays in the track. So you're running around, and we must have some track people here. You're running around in this track, or if you're doing the skating, and then you cross over. Anyway, you have to stay on the track, obviously. But you want the shortest distance. So if you end up here on the outside of the track, you can cut across here, and that would be your length. That's what it's asking for. I just thought it was kind of a strange question. You have one just like it. It's the last problem on the worksheet. So I'm going to pull that triangle out, because there's a lot of stuff written there, because it's a right triangle, which is nice. This is 24. This is 30. I would like to find out how long this segment is. If this is x, then how long is this? If this is x, no. If this is x, I don't know how long it is.
48.
Then that's x. They're equal. These triangles, if I draw a triangle here, those triangles are congruent. We haven't done congruent triangles. No, it's not a 30, 60, 90, is it? Because remember I told you, if you told it's 40, are you told it's 45? You don't know that. You either have to come from a square or equilateral triangle, or you got to be told. I remember that about teaching this years ago. Instead, we can use Pythagorean's theorem, because that always works. Well, I'm going to make this easier than that. I'm going to take this triangle, because there's a common factor here, and I'm going to shrink it down. What goes into both 24 and 30? Because this is a nice technique if you can get it. Because easier than simplifying radicals. So this is going to be what? 4. This is going to be 5. I reviewed the special triangles. What does this side have to be? 3. Good. Now, I divided by 6 to get this direction. I want to go back. So how big is this? 18. You got to multiply 6 times 3. So this is 18, and that's 18. So what's the total length?
18.
No. 18 and 18 is 36. Now, at first glance, the problems are kind of scary looking. But you start breaking it down, start drawing in your right triangles, you can do something. You may not get to the end, but you can do something. Okay, I think we still have another one. And this one's on the worksheet. This is problem 2. And that one's kind of scary looking, too. I want the shaded region. So, what shape is this? It's a kite. So then I thought, well, maybe I should use the area for a kite, which is, and does anybody remember? D2 divided by 2. So I didn't think that was easy because I don't know either diagonal. So you're right. I have the area of the kite. And what do I want to take away? I have this full area here, but I don't want that area. I want just the shaded region. So what am I going to take out of it? Part of the circle. Not a semicircle, but, you're close. So it's minus the area of, and that's called a sector. Okay, the kite is tricky. So maybe you get stuck there. You can do the circle, though, can't you? What part of the circle is this? Look at the picture. What fraction is it? 1/3. It's 120 out of 360 pi r squared. I'm not even going to put in HA yet. Could I break the kite into 2 things where I could find their areas? But some of you guys did that. What if is that an R? Draw RH. What kind of triangle have I got here? A right triangle. That's 90. How big is this? The whole thing's 120, so this has to be what? 60, because these 2 triangles are identical. Okay, I want to pull that out. There it is. That's 60. That's right. That's 30. And then now, I'm not going to put the numbers in yet. Let's label it. What's this side? 2x, that's the hypotenuse. Then I go to the short leg, which is opposite the 30. We've got to get that concept of opposite. It's across the pond. Okay? That's x, because we're going to do trigonometry, and we have to know that. Then what's the long side? Long leg, I should say. X square root of 3. Okay, Now I'm going to put in what that is. This is 8 square root of 3. So this is 8 square root of 3. What's x equal to? So x equals 8. Okay, so now let's get the plan here. And I could put all my pieces in. This is 8, and this is 16. So I do have one diagonal. I don't have the other one. That's okay. I didn't want to go there. It's too hard. So how do we find the area of the kite? How many triangles are there? 2. So I've got 2 triangles, which is 1/2 base times height, minus 1/3 of the circle, pi r squared. And I think maybe I better label my picture here so I can find things. I've got everything I need. This is 8. Okay, what happens to the 2's? They go away because I got 2 triangles. What's the base and what's the height of that triangle? And the height is 8 times the square root of 3. That's why we did all that radical work, so you'd know what to do with this. Minus 1/3, and what's the radius of my circle? Look at the picture. It's 8. No, you don't have that many numbers. Grab one of the numbers at least. The whole circle is 64 pi. So this is 64 square root of 3 minus, whoops, forgot to square it. 64, I usually like to write the pi at the end, over 3. You could factor out a 64 if you wanted to. You get left with the square root of 3 minus pi over 3. And I don't know what to do with that. That's what I love about algebra. I don't have to do anything with it. Just leave it. The first answer is fine. This was just to show you there's nothing you can do with that. Okay. Is that it, or is there one more problem? I think there's one more. Oh, that's it. So, are they that bad? Yeah, they look hard in the beginning, but when I start thinking out loud, I start drawing my pictures, I'm looking for right triangles, then it's not so bad. What we're going to do now is I'm going to hand back your quizzes. They are not recorded. So if I don't get it back, you get 0%.